Hi, I'm Victor, and this is what scientists call a stone. Now, it can only exist in one place at one time, so it behaves like a particle. That's pretty obvious. This is a wave. Unlike the particle, it does exist in many places at once. Light. What is it? And is it made up of particles or waves? Let's do an experiment. In the double slit experiment, we shine the light through two slits. If light were made up of particles, they would land in two neat clusters. If light's made up of waves, things get a little more complicated. This wave splits into two, and then these two waves interfere with each other, so they add in some places and subtract in others, making an interference pattern. I'm using this laser as a light source. It provides a more concentrated beam of light than the flashlight. So, when I shine it through these two tiny slits, you can see a clear interference pattern on the wall. So light from one slit must be interfering with light from the other slit. This proves that light is a wave. We've just proved that light is a wave using nothing but two slits. That's pretty cool. What do you think would happen if instead of the light, we fired individual atoms at the double slit? Well, atoms are just tiny particles, because like this stone, they exist in one place at one time. So you'd expect to see them land in two neat clusters, right? You want me to show you the actual results? This looks a lot like an interference pattern. But how is this even possible? Why aren't the atoms just landing like they're supposed to? Well, the answer to that question literally created a new type of physics. Quantum physics. Now, I know it sounds crazy, but it turns out that the atom does exist in many places at once. You know what else exists in many places at once? This guy. We call this wave a probability wave, because it represents the probability of finding the particle at a certain point. This wave interferes just like any other wave, making regions of high and low probability of finding the atom. The probability wave hits the screen, and that's when it collapses onto a single point, like a particle. So the atom behaves both like a particle and a wave. We've just discovered the wave-particle duality of matter. Remember, all matter is made of atoms, so all matter is made of probability waves. You, me, this stone, we're all made of waves.